Alright, not really sure how far we'd gotten on the last one with balanced forces, but I believe we were trying to deal with the situation right here, which was balanced forces in opposite directions. So if they're in the same direction, you want to make sure you go and add them together. If you're in opposite directions, you want to go and subtract them. So 5 and 5, 5 minus 5 would leave you with resultant, or in this case here, a net force of 0 newtons. Resultant net force. The big thing to think about this on a lot of the times when we're talking about balanced and unbalanced forces is if there is a resultant, there is motion. Resultant no motion. And usually the resultant again is in the direction of the strongest original force. Alright, so unbalanced and balanced forces. I told you I would not be asking questions about inertia. I would not be asking questions about normal force. Newton, I think I mentioned it already, but number 9, Newton. What is the Newton used for? The Newton is used, I'm probably missing this ever so slightly. The Newton is used for measuring force. You could have seen it on your paper. Alright, let's see. You'll notice there, actually this is a question that showed up a little bit earlier in your one of your worksheets, but it's asking you to accelerate 1 kilogram mass per 1 meters per second squared, you need 1 Newton. Alright, so that just happened to be one of the questions from the worksheets. Alrighty, let's zip on here. Gravity, I don't think I need to go over that. 10, gravity. The only pull, and obviously it's, gravity does exist between all objects that have mass, but it'll be the only pull that exists between 2 objects. Alright, let's see. Net force. Kind of already mentioned what the net force is. Bring this back here for you. Net force, for the most part, you got it, it's the resultant. So net force, number 12. That is indeed your resultant. The sum. Makes sense. Sum. Let's go on here. Number 13. Number 13. This one we haven't had a chance really to discuss too much, but once we get talking about Newton's 3 laws of motion, momentum will definitely show up. But momentum is basically something that can be calculated using the product of mass and velocity. So I'm just going to say mass times velocity. And I'll give you an example. If 2 vehicles, you have vehicle 1 and you have vehicle 2, and vehicle 1 has a mass, let's make just a random number here of 1,000 kilograms, and vehicle 2, a much smaller vehicle, only has 100 kilograms, and that'd be a very, very small vehicle, like a bike maybe, maybe like a motorcycle. So 1,000 kilogram vehicle and a 100 kilogram vehicle, and if they're both traveling at the exact same speed, so we've got the large truck and it's zipping along at 50 kilometers per hour, and then we have the teeny bike I'm not really sure how this is going to look for you guys. And it also is moving at 50 kilometers per hour. And we were to go and stop the engines pushing both these vehicles at the exact same time. Which vehicle would have a greater momentum? Simple enough, the one with more mass. At which point that momentum could be translated into the vehicle rolling further than the lighter vehicle. So think of momentum having a great deal of an idea in regards to how much more a vehicle responds and rolls. A great process would be maybe on the highways when 18-wheelers are coming down the hill. They like to get as much speed as they can so that when they go up the next hill, they have enough momentum to make it further up the hill. Just another thought process to kind of use to remind yourself what momentum is. But in essence, it's your mass times your velocity. Excellent. Let's see here. Skipping number 14 and heading into 15. 15, again, reference point. And this is that classic example reference point. Your reference point would be used to determine if an object is in motion. You'll remember the example in class was the bus. You had the feller on the side of the road there. Object A. We had a bus zipping along here. On that bus, object B. On the bus we had a woman sitting in a chair. And as she sits in the chair, we'll call her C for chair. And if we were to compare the reference points of A and C, or even A and B, we would say that there is motion. Because the distance between the two objects is changing. But if we were to compare between B and C, we would say no motion. Their distance is not changing. You know, barring any possibility that the bus driver slams on the brakes and this poor woman goes flying out the front window. So, anyhow. Reference point, check. Let's see what we've got over here. Next up is motion and acceleration. Easy enough. Motion and acceleration. Some of you will remember quickly. Something is in motion when distance between two objects changes. Maybe some of you will remember the very first worksheet with Ashley and her brother. They were biking together, and because the distance between her and her brother was not changing while they biked together, they weren't moving relative to each other, but they were moving relative to everything around them, assuming that things were stationary and or going in other directions. So motion is the distance between two objects in change. And last but not least is number 17. Number 17 is kind of a difficult one here, but if speed is related to motion, velocity is related to acceleration. So if we can go and see a change in velocity, so a acceleration is a change in velocity with respect to time. So here's a great way to think about it. 3 major ways that something is accelerating. You speed up, you slow down, or you change direction. It's a little bit of a miscommunication or a misconception for a lot of people, because people think of when you step on the accelerator in a car, you only speed up. Well, stepping on brakes, that's also a form of acceleration. And changing direction, well, here's a great way to remember if you're accelerating or not. If you can feel the motion, you're accelerating. So when someone hits the gas really hard and you feel yourself being pressed back into the chair, you're accelerating. If someone hits the brakes really hard and your seatbelt stops you, you feel acceleration. And if you're going around a turn and you feel yourself getting pulled to the side of the vehicle, that's also acceleration. So any of those 3 things are what we consider to be acceleration. And all of that is a change in velocity with respect to time. Alright, You guys have a great night. Enjoy the study, and I will see you all tomorrow. Take care.